Mr. Investor, welcome back to the channel, baby. You're going to love this video here because it's very interesting. We're going to cover customers, including drug companies that are utilizing the Saphyr system. Very interesting. We are going to be looking at jobs that have popped up for optical genome mapping. We're going to look at some conferences from around the world where they are filling out rooms, as well as talking about what customers think of optical genome mapping and where they can see themselves in the future and where they can see the adoption. Before we begin, I've been doing a lot of research. Please remember, all of this is for entertainment only. It's not financial advice. Bionano genomics as well is on the verge of a reverse split. We don't know when the reverse split is going to be. There's no date yet, and we don't know what the ratio is going to be in terms of the reverse split. Also, if you like this video, please hit the thumbs up, drop the subscribe button, hit me some comments down below, and let me know your thoughts and feelings on the opportunity that is optical genome mapping. Let me know about the management of funds, the management of the company, your thoughts there, because I know a lot of people are very upset. And zoom out as well and tell me if you see, if there's a bigger picture, if there's a way that they can transform this company into actually being profitable in the future. Can you see this opportunity or not? And thank you to my channel members. Thank you to everybody that dropped me donations. I really appreciate it because we don't make a lot of money on this channel, and it's just nice to feel appreciated for doing, you know, lots of this research and just feeding it back to you guys. Okay, let's begin. Let's get into the nitty gritty. So first of all, the genome editing market, professionals within pharmaceutical companies are currently using optical genome mapping, and we're going to explore that in just a minute. But I just want to show you the genome editing market size. A lot of new gene therapies are being created. There's, you know, CRISPR and lots of this stuff here, lots of gene editing going on. The market is said to hit around about 21.36 billion by 2030. Other analysts indicate that it could hit a market size of 20.3 bill by 2030. So now the drug companies, the pharmaceuticals that are utilizing it, that we can know are utilizing it, is AstraZeneca. Currently they're using optical genome mapping, and this is the associate director Sumaya, who actually was part of a conference. I think she also attended the symposium before. So it says that she's operating out here in Sweden. So how do we know that she's utilizing the Saphyr system? 2023, this recent article was looking at the safety of genome editing based therapeutics. So they're looking for approaches where they can analyze the safety of it. So I'm going to read you the little bit of this abstract just so you understand it. If you like this video, hit the thumbs up. Let me know how you feel. So here you go. Genome editing based medicines are a new therapeutic modality being developed. They show great promise for a spectrum of genetic diseases lacking conventional treatment strategies. One of the major obstacles that prevents the therapies from reaching the clinic is their safety. So they're focusing on the development and establishment of these new approaches to capture and understand the safety risks during drug development stage. So they want to build safe drugs that would reach the clinic. So to capture the potential off-target double-stranded breaks that are generated by CRISPR, they're using next-generation sequencing-based methods, induced-seq. And then in terms of the larger scale on and off genomic genetic changes induced by CRISPR editing, which are difficult to capture by next-generation short-read sequencing, they are employing a novel image-based long genomic technology called optical genome mapping. What does it do? It enables the detection of on-target integration with a allelic frequency as low as 0.001%. It uncovered previously unknown on-target allelic integration heterogeneity, and it found several off-target structural variants genome-wide, thereby proving that optical genome mapping is highly sensitive and can detect rare and complex DNA structural variants, which would have been missed otherwise. Now, if we scroll down, we can see here, it says Handler, Handldare, Sumaya, AstraZeneca. So potentially, if they're looking at it as a way to assess these new, you know, gene editing based medicines that are being developed, it's really important. If they're assessing the drug development stage and looking at the safety risks, and they need not only next generation short read sequencing, but they need optical genome mapping for the larger structural variants. With a multi-billion company like AstraZeneca, a huge company. I remember seeing also Pfizer pop in. There was some Pfizer executives or some part of a research team, they were popping into the symposium as well. But to see AstraZeneca actually actively utilizing optical genome mapping and saying how useful it is for in terms of these gene editing therapies, you know, there's a world of opportunity there, especially if they can establish it and put it as part of routine for assessing their safety risks. Now, if we go back into bionano genomics, I wanted to take a look at this. So now this was interesting. This is from their strategy day. So this was their 2022 estimated annual consumable revenue per system. And they said pharma and biotech runs about $73,000 per system. But this could be a lot more, especially if it scales up. This was only a 2022 revenue. And if Saphyr does manage to put this as part of their routine in terms of, looking at safety risks during drug development stages, pharmaceutical companies are constantly progressing and they're constantly researching new drugs. Gene editing is very new as well. It's going to be around for a long while. And there's currently lots of progress and lots of therapies that are being approved by the FDA. How do you know that? You're just saying a generic kind of information. No, 5 days ago, this was published. Food and Drug Administration approved cellular and gene therapy products. List of the kinds of drugs, the kind of gene therapies and cellular therapies, the products, and it also has the companies it comes from. So Bristol Myers is here. You have universities there, blood centers, and they're showing all the different types of gene therapies that have been approved. And this has just been put up in the last 5 days. This Zolgensma as well. This one's for spinal muscular atrophy, I think. One of the most expensive, gene therapies that I saw. I think it's $2.1 million or 2.5 or something like that. And it's a single injection you give before the age of 1, and it will stop someone developing spinal muscular atrophy or slow. I think it might slow it so they can have a prolonged and better life. So this is very interesting, and the NHS also has approved it, and they're paying the $2.1 million. Yep, there we go. How much does Zolgensma cost the NHS? UK's National Health Service just approved the drug that costs nearly $2.5 million a dose. It's the most expensive drug in the world, according to NHS England, and this was a statement in 2021. So now it's been FDA approved in the last 5 days in America. So moving on, there's positions that just got filled. You can see here, first stage researcher in Belgium, in Brussels, looking for opportunities in optical genome mapping and long-read sequencing, particularly looking at improved cytogenomic diagnosis in lymphoma. They called OGM and long-read sequencing emerging technologies. They combine genome-wide detection of numerical and structural variants in one assay, overcoming the limitations of current testing strategies. This project focuses on the implementation of these novel DNA-based techniques in routine clinical care to enable standard of care testing for all newly diagnosed lymphomas, and intends to improve classification for entities where genetic understanding is currently limited by investigating novel recurrent variants in rare and aggressive lymphoma cases. So this is really exciting, this project, and you can see here that it's over in Belgium. Over in Canada as well, later on in this video, make sure you watch to the end. You're going to see I've been speaking to Adam Smith, who is a key genomic leader out of the University Health Network in Canada. And he's just stating, they think it's revolutionary, optical genome mapping. He said how many, flow cells he's currently using, or how many he's planning to use in the next couple years, how many genomes he's running, and current cost as well, how much he's paying per Saphyr chip, cost per genome. So it's really exciting to see. He also stated how long he thinks adoption is going to happen in terms of hematological malignancies. We can see here that, Europe has taken an interest. We've got it over in America with Praxis Genomics, and we've got it in Canada with him. So we're seeing it utilized especially in Spain as well. So there's conferences worldwide, and it's exciting news because this could be the first time that bionano genomics can get some regular income, and they can really breach into a certain market, going into blood cancer first. So they were focusing on cancers and rare disease, but they believe their fastest way to market and to get revenue from the labs is through cancer, particularly blood cancers. Nice. Over in LinkedIn in the last 7 days, we can see Bionano has stated that genetic testing is crucial in improving treatment options for reproductive health issues. So optical genome mapping is going to be utilized. It can increase findings for pathogenic structural variants that lead to rare genetic diseases. And they're saying that optical genome mapping is also a tool that helps researchers better understand the underlying genetics and the etiology of recurrent miscarriage, infertility, and pregnancy abnormalities. Now, the next one I want to show you, this is really interesting. This one here, Institute of Applied Biotechnologies. So over in Czech, optical genome mapping meeting in 2023 on June 21st was an incredible success. So they've stated, thank you to the professors that they have, Sarkar, thank you to the institution as well, the hosting institution, Faculty. So they were demonstrating, optical genome mapping, talking about it, and just look at how many people were at this event. It's insane. And it was purely for optical genome mapping. Look at that room. Just look how many people were there. Just look how many people in this room. I'll just make myself a bit smaller. There's so many people in this room, so much interest gathering across Europe for optical genome mapping and the Saphyr system, particularly with blood cancers. You can see there on the screen, I don't know if you guys will be able to see this. It says bionano on the top left there, and it says AML. Then you can see here bionano more clearly, increased detection of chromosomal aberrations with optical genome mapping full house. So this was people presenting optical genome mapping. It gathered researchers, clinical professionals, and experts in the field of genomics, and they want to collaborate. This event, they were overwhelmed by the interest in the community. And it goes to show you, them just saying bionano that people are interested, interest is developing, this and that. Them just saying that at presentations doesn't really mean anything to us, especially if you've been here for the long run. It's just like, we need proof. We need to see this. And this interest is popping up across the world. And a lot of researchers, a lot of people who are utilizing the machine, the system, are all saying the same thing. It has clinical utility. It depends on what they're doing at the moment, because people are using the Saphyr system for different use cases. But yeah, this is really good to see. It's going to fill in later on into this video. You're going to see a bionano customer said what he thinks the adoption time rate and time scale is going to be for the US, for Canada, and for Europe to adopt the Saphyr system. So now moving over into the UK, they really want to lead. They want to be a leader in the worlds of genomics and precision healthcare. So a lot of things are changing, and with improved diagnosis and targeting of treatments in common and rare diseases to preventative measures to prolong healthy lives, genomics has the potential to impact our well-being whilst also improving the cost effectiveness of the healthcare systems we have here. This was from 2022. At the end of it, Baroness Blackwood was writing this article, and they stated that United Kingdom is acknowledged as a world leader in genomics. It's becoming a scientific superpower, and they're just a little wary of doing that claim. But just take a look at the NHS plan. They've also stated they're the first country in the world to provide genomic medicine through a national health system. Already implemented whole genome sequencing as standard of care in the NHS for rare disease and cancer patients through the NHS Genomic Medicine Service. Stated that they believe this is, the beginning of the end for diagnostic odyssey, where, patients, look at this patient, for example, Alex, undiagnosed for 18 years, had 28 serious operations because of his symptoms, including removal of tumors, several bouts of heart surgery, before he found out that he actually had leopard syndrome. And it's only genomics that would have found this for him. So let's go over to the strategy. The genomic strategy for the National Health Service in England. If you look at point number 4, not only do they want to enable genomics for everybody here in the UK, and they want to embed it into their service, they want to evolve the service through cutting-edge science, research, and innovation to ensure that patients can benefit from rapid implementation of these advances. One of these advances being, if you go to their 2.3 on the NHS strategy, their 5-year strategy, priority 2.3 says enabling the rapid evaluation and adoption of affordable, efficient, and innovative genomic technologies. One of those technologies being, or two of them, long-read sequencing and optical mapping. This one right here. And there's a few NHS hospitals, NHS research centers and labs, and genomic medicine services that have already adopted the Saphyr system, and they're just piloting it at the moment. We're trying to find out, is it cost effective for them? Has it got a high enough throughput to meet their needs? So currently I'm emailing some of the scientists to try and figure this out. Genomics in the UK is also pushed upskill nurses and make them genetic counselors. So here they're stating, free licenses for nurses wanting to up their knowledge in genomics and put it into clinical practice. Over the last few years as well, we've been seeing grants galore. In 2022, BBI provided $50,000 to evaluate the performance of novel diagnostic techniques. Funding was enable the mentoring of a UW medicine fellow and compare optical genome mapping with proximity litigation sequencing. To show you as well where some of the grants are going. So some of the grants from charities, this is a release from Harry Perkins Institute in 2022 as well, and I'll show you why this is relevant today. So a bionano Saphyr instrument will be installed in the diagnostics genomics Pathwest in a collaborative partnership between the Harry Perkins Institute, Pathwest, and FSHD Global Research Foundation. So the foundation gave them $516,000 to purchase the bionano instrument and reagents, and the appointment of a medical scientist to get the machine running. FSHD causes progressive muscle weakness and wasting, making everyday tasks like walking, talking, smiling, and even eating impossible. This is over in Australia, right? And I'll show you a release from just recently. This is actually a new release. The Muscular Dystrophy Association put this on their LinkedIn, and then I clicked the article, found it here. It's the first approval for a gene therapy for DMD, which is Duchenne muscular dystrophy. Duchenne muscular dystrophy, FSHD is the third most common type of muscular dystrophy. It's behind Duchenne and Becker muscular dystrophies, right? The application of optical genome mapping 2023. At present, OGM has been applied in the detection of many genetic diseases such as Marfan syndrome, Duchenne muscular dystrophy. This gene therapy that's been developed is called Elevidys for the treatment of Duchenne muscular dystrophy, designed to target the underlying cause of disease. So if optical genome mapping can be used as a screening tool for DMD or for FSHD, and if they're developing therapies as well, or if after gene therapy they need to track it and take a look at, is anything else changing, or even as part of the safety and the risks, if they're using the optical genome mapping system to identify and look at any changes in structural variants too, this also could be a market for bionano and the Saphyr system. Alex Hastie, the Vice President of Clinical and Scientific Affairs, right there on bionano, he released this 18 hours ago talking about a paper that was coming out of UCSF and the National Taiwan University describing the discovery of a new microdeletion involved in Charcot-Marie Tooth disease by optical genome mapping. So what did they do for their study? They conducted full genome analysis by utilizing whole genome sequencing and whole genome optical mapping. This disease can cause curling of toes and also high arches on flat feet, hand tremors, muscle pain, numbness, cold hands and feet, drop foot, chronic fatigue. It can really affect a patient's life and they can be on a diagnostic odyssey, and it can really help out by mapping the structural variants and getting diagnosis. So they've reported that they've used, bionanogenomics Saphyr system as part of their study, and it helped reveal and help them look at a full genome analysis approach and find this new microdeletion. According to the National Institute of Health, the prevalence of CMT cases was 15.7 per 100,000. The highest prevalence being between the ages of 50 to 64. There was 25.2 per 100,000, and males had a higher prevalence than females at having this disease. Next, Saphyr system, just landed in Stanford. Birgit Shu has stated that she's excited, the first instrument for optical genome mapping is now at Stanford. And what does she do? Birgit looks at Parkinson's. So she does disease research. Her research improves patient care by unraveling the causes of neurodegeneration. There's about 10 million people that have the condition worldwide, according to Parkinson'sEurope.org. It's less than 1% of the total population. It's still a lot of people. 10 million people is still a lot. Look at this as well, this excitement. Really happy to have presented my poster yesterday at ESHG 2023. This is Bruna Berced, and she is presenting this. She said, working with optical genome mapping seemed like a distant dream not that long ago, but it became true, and now I got to show some of the incredible things we discovered with it. Complex rearrangement involving a three-way balanced translocation detected by optical genome mapping. And it looks like she's coming from Brazil, over at Universidade Federal de Sao Paulo. Save the email for the next video, but I want you to take a look at this. This is Tyler Wilding. So he said, achievement unlocked. 2 months ago, he was doing some of his master's work to present at the British Society for Hematology conference last weekend, assessing bionano optical genome mapping's ability to detect structural and copy number variation in hemato-oncology. So it seems like for blood cancer, it's really useful. It's super useful, and he's excited to have researched it, and it's part of the Central and South Genomic Laboratory Service as part of the National Health Service here. I was wondering in future, will they be able to use this as part of routine care in the National Health Service? Actually, I'll show you a little bit of the email, but I'll probably repeat this over in another video too. I was speaking to Adam Smith over in Toronto, and we were talking about bionanogenomics. This gentleman is the director of Cancer Cytogenomics Laboratory, University Health Network in Toronto. So he stated Spain is really embracing optical genome mapping, because I asked him about Europe. I don't know exactly how they're funding it, so I don't know what their volumes will be like, but the interest is there. I presented at that meeting, but there were half a dozen other local presentations on optical genome mapping. So Spain is definitely out ahead. I wanted to ask him about screening tools. So I wanted to see, I saw a grant from 2021 or from years ago, and somebody was exploring, I think it might be Dr. Ebert. They were exploring Alzheimer's and trying to see if they can develop a pre-symptomatic screening tool for Alzheimer's diseases. Spoke to Adam, he said, it's a bit tricky. For screening, it has to be cheap and demonstrate a clear benefit. So optical genome mapping has a couple problems there. It's expensive for a screening test, and in the diseases we are looking at, there is no early intervention. So he looks at leukemia at the moment. There are conditions like clonal hematopoiesis of indeterminate potential. There can be mutations or structural changes, but we can't do anything except watch and wait mostly. One area that might be interesting is disease monitoring. We know that leukemia that can go into deep molecular remission have better outcomes, but testing is difficult because you need a marker to track. So optical genome mapping might be useful in some settings. I think we'll see more adoption and uses, especially as the price drops. In terms of price, I emailed Adam and I was asking him about, if optical genome mapping reaches $100, will it make OGM accessible worldwide? I'm wondering when the inflection point will be, when we'll start to see large-scale adoption of optical genome mapping. I think you guys are really ahead of the game in transitioning to OGM from conventional methods. How long does it take to process and get the clinically relevant information for one blood cancer sample? Is the total turnaround time around a week? Also, with variants of unknown significance, do you think there's a time, as time goes on, we'll solve or understand these better? With clinicians and pharmaceutical companies, a friend suggested that the earlier the diagnosis and defining cancer type, the earlier treatment starts, better the chances of survival. So it's more lucrative and in their interest for big pharma to support OGM. Clinicians benefit by using cancer genomics to find targetable, actionable sites to utilize personalized treatment. Do you think OGM can be utilized by big pharma to help develop new treatments and medications for blood cancer? Adam replied, he said, I don't know if the cost will get down to $100, but even $250 would make a huge difference for adoption. The problem with adoption outside the US is always questions about variable currency exchange rates and markups via intermediaries and custom import barriers. So the lower the cost per genome goes, the better. I think Canada, USA, and Europe adoption will be speedy. In 18 to 24 months, we'll have widespread adoption in those places. Cytogenetics people are really excited about it. It takes us about a week from sample to report. That's about the fastest we can go, and it's comparable with karyotype. The variants of unknown significance are a real interesting area for potential discovery. I think we'll see a lot of new genomic discoveries over the next 5 years. For a lot of these, we need the right kinds of clinical trials or prospective cohort studies. However, that will take some time. Detecting cancer earlier doesn't often happen in acute leukemia, as the onset is often quite rapid. Leukemias are a bit different from solid tumors in the opportunity for a cure based on stage at diagnosis. But I think there is enormous potential at developing more targeted therapies that reduce the reliance on chemotherapy and real quality of life improvements for cancer patients. We support a lot of clinical trials at PMH, and most pharma companies are really excited about OGM once they understand what it can do. As we can see by AstraZeneca, who's already been utilizing it if you watch the beginning of this video. What am I doing in terms of finances and stuff like that, in terms of dollar cost averaging, or trying to obtain more shares, and with the reverse split coming and the need to raise capital and how we're getting diluted? For me, my strategy right now is I've got 54,000 shares. I'm not planning to buy any more until after the reverse split and after the capital raise. For me, I'm zooming out and I can see the bigger picture. The only reason I haven't sold, as soon as they announced that reverse split, the only reason I didn't sell is because I zoom out and I look at all of the research, all of the studies, all of these professionals, all of the meetings and presentations where people are interested in optical genome mapping. And I look at the opportunity of how it can be embedded into clinical care. I look at like the routine clinical care, and I look at like the clinical utility, looking at how different research labs, pharmaceutical companies, then you have medicine services, genomic medicine services utilizing the Saphyr system. Looking at the potential that it can actually happen, is what's keeping me here. The management and how they've burnt cash and making those acquisitions, they have a deeper understanding of genomics than I do. Although we were really upset that, they've blown through cash and we're getting diluted. I'm looking at it as a bigger picture and how they're creating this kind of one-stop shop, this one-stop system for, sample prep, them getting the Saphyr system, having the different types of flow cells and different types of kits ready for them, and then genomic analysis with biodiscovery afterwards as well, and having a platform where people can share optical genome mapping data. If all these researchers are coming through saying, wow, we used it for this, we found this, we're using it for drugs and safety, we found this. If we're using it for cancer, we found out, these structural variants, we found this, and we can develop therapies of this. If all of them are combining data and they put it onto a platform afterwards, and they're able to share that data, it's going to further advance optical genome mapping. And this blue ocean that you see, Nabsys has been raising money recently. Competitors are trying to get back into optical genome mapping game, or optical mapping, some other competitors. But it makes me think that the opportunity is there. And am I just a bit too early? Is this company struggling a bit because they're just trying to create this blue ocean? And if they do manage to do it, what will that mean in the future for finances? And how long will it be till I'll be able to get return on investment? And if they get bought out early and my cost is high, and I didn't dollar cost average down, does this mean I'm just going to lose money and they'll get bought out and I'll be given some cash that will be less than my initial investment? These are the things I'm considering and looking at. Will they run out of money and I think they'll keep ATMing? If there's any problem, ATM, they'll just reverse split ATM, which will just damage shareholders, but it will increase their chances, of reaching their goal, their potential in helping human health. And hopefully somewhere between that, they'll look at shareholders and they'll think we need to return this value to shareholders, because we've been here from the very beginning. We've been here since, that meme stock, when they were going to reverse split before, the meme stock frenzy, and how they're saying bionano got caught up in it. It got caught up for good reason though, because if you look at everything that's being published now, it's like optical genome mapping has a real place in genomics, a real place there. Looking at structural variants, large scale structural variants, long read sequencing may be pushing the boundaries and coming closer to eating up space in the market. It's, for me, I'm not sure because I'm not a genomics expert, but for me, I think there will be a place in the market for optical genome mapping alongside short read sequencing and long read sequencing. And I don't know if they'll be able to develop something that does everything in one. I know bionano genomics still has that patent to effectively turn it into a sequencer. So I don't know how that's coming along with the nano nozzle, but if they do manage to do that as well, what is the market going to value bionano at then? Because we start to eat into the sequencing market. So that being said, I hope you enjoyed this video. I hope you enjoy my entertaining opinion only. This is not financial advice, entertainment only. What I'm doing is waiting until after the reverse split, waiting until the dilution comes, and then I'm going to be buying more shares. But this is only my plan. I know a lot of people have chosen to exit. They're not happy with management, this and that, but I'm still looking at the bigger picture, the greater opportunity. I'm not looking at, how much I'm down at the moment. I've invested so much into this. If you understood, I took my life savings, I put it into not optical genome mapping. I put my life savings into Occidental Petroleum. I took a 300%, between 200 to 300% profit on that. And I took all of that money. So I think it was 12.3K turned into 40 plus K. I took all of that money and I bought bionano genomics shares. I was trying to buy it at below $1.50 because looking at this company, if they do manage to get that total addressable market of, I don't know what it is now, 10 billion, even if they're able to get like a 1 billion revenue per year, how big will that company already be? What would the market cap be on a company like that? What would the market value bionano genomics as then? But yeah, there's a long way to go. And also they put into their presentations, will they ever be profitable? Will they continue having to raise money from investors? So yeah, there's lots of considerations, and don't follow anything that I say as financial advice. It's for entertainment only. You have to make your own decision based off the research that you do. And yeah, I wish you guys all the best, and I hope you have a lovely week. So I'll catch you in the next video. If you appreciate a video like this, I know it's really long, but I just wanted to give you the best and the best kind of entertainment I could, and bring as much value as I can to this YouTube channel. But if you do appreciate the video, please hit the thumbs up, subscribe. You can drop me a donation. There's a link in my description box below, so there's a donation box for PayPal. I really appreciate it, and I really appreciate you guys who come back every week or however often I can make a video. I appreciate all the comments and I appreciate all the feedback, and thank you for supporting this channel. Mr. Investor Lot over and out, baby.